Hello and welcome to another episode of Invalid Entry. My name is James Taylor. Today what we're doing is we're looking at a presentation I gave to nordevcon, which is the Norfolk Developer Conference in 2022. I gave it about 4 or 5 days ago now. And it was well received, and I've been asked to re-record it and put it online by a few people. What I talked about was system architecture. And I talked about into 3 phases, and really talking about how system architects became a thing, what system architects do all day, every day, and then finally some tips and tricks on how to do better architecture, especially systems architecture. I don't really touch into specifics of architecture, so I don't talk about coupled systems, strongly coupled, weakly coupled, or anything like that. I don't talk about API design. All those are big topics in their own right. But I wanted to just sort of go through this presentation as it was. So I am James Taylor. People call me JT. Actually, very few people call me James. I think my mother calls me James, and that's about it on the list. When I built this slide deck up, you have to sort of say who you are and what your experiences are, and I absolutely hate this slide. I mean, it looks fantastic, but I hate it. It feels like I'm bragging about myself and my accomplishments. Many years ago, about 20 years ago, I read a book about secure coding, and the author, spent the first chapter just bragging about who they were, about they'd done consultancy for the White House, and it really annoyed me because I wanted to read the book and decide what truth that book had for me, what the knowledge they actually had. I wanted to get to the knowledge and have that for me. And I realised after a bit that actually some people do care about this. They do care about what experience I've had because they want to know whether it's worth listening to the rest. So yes, I've been paid to do IT work or computing work over 23 years. I was earning money from IT before I was even a university student, doing IT support at local businesses. I've done startups, I've done enterprise organisations. I currently work at a scale-out organisation. It says multi-award winning, but don't ask which awards but I have actually won several computing awards. I've won several business awards. I've been part of businesses that have won awards. I've been given individual awards by the companies I work for, by other organisations. And I currently work for a company. The reason I haven't written down who I currently work for is because I haven't run my slides past legal teams. Marketing and legal have to have a say, just in case I put anything in the slides. Because of the nature of the business I now work for, it can be seen as advice being given, and they could be liable for that advice. And I'm not qualified to give certain kinds of advice. I work for a financial institution, and therefore if I were to say certain things like buy NFTs, they're a sound investment, they're not, in my opinion. But also I'm not a legal financial advisor, so I can't say those kinds of things. So they asked me not to say who I work for. Hilariously as well, every single organisation at Nordev, we're also saying we're hiring, and the company I work for is hiring as well. So if you're interested in a job, just email careers at the company that I work for that I can't say I work for. So, and say I sent you as well, because I might get some money that way. So have good fun working that one out. Maybe lost it. And of course on my YouTube channel, which you must know if you're watching this video, so fantastic. As I said, we're going to try and hit 3 main areas. I'm going to try and make this in under 45 minutes. I might not be successful. So I broke it down to 3 chunks of 15 minutes, talking about what an architect, how we got to this state of architecture, and then finally getting through to where we are right now. So first of all, let's go back in history. Let's cast our mind back using the harp. Many years ago, and the picture on the left here of 2 ladies they're effectively coders. These is actually from the 1950s US census, so they're not actually doing coding, they're doing data entry, but they're using punch card machines here to actually enter data onto cards. Whereas the lady on the right, she's actually programming. This isn't my mum, but it could be. This is a picture from the late 60s, maybe early 70s. She's an IBM programmer here. You can see that she's drawing by hand a flow chart of how she wants the program to work, and she's solving the problem that she's being tasked with. She understands there's data, maybe she's writing to tape, there's information that she's trying to work out, and she's programming. Right now she is programming. That's what programming used to be. What would happen is you would write your program out, maybe write it in a flowchart, or maybe actually write it then out in words, handwritten, and send it to the typing pool, which would generally be young ladies typing. I suspect, before anyone claims sexism, I think they're from a certain social economic background, and quite often, according to my parents, both punch card programmers, they often didn't really care about their job, they didn't really care about accuracy, so they would just type it up and send it on its way. They then go to the computing room, where your program runs, and 2 or 3 days later you get your results back saying that you had a typo in line 4 because someone typed it in wrong. There was a level of sexism going on here. That was young ladies here. I suspect if you were a young man from the same sort of background, you'd probably been sent to somewhere like the mail room or something like that. I was thinking on this day, I think about every single email I get would once have actually been hand delivered, which is a crazy idea. But yes, there was a distinct split between coding and programming was someone who was trained, had university degrees, knew what they were doing, put a lot of thought into what they're doing. Whereas at the other end, you have people who were just copying out. So the coding part of it was expensive because it took away from your programming activities. Throughout the years, we started getting things like interactive terminal. So before we go on to that, my parents actually found it was better for them to do the programming themselves. And actually, this lady on the right here is using a single-hand punch typer. If you actually sent to the typing pool, they would use a two-hand machine, which was like a typewriter and actually printed what the letters and things were above the holes that you were punching, so you knew when you looked at the card what it said. This single-handed punch card didn't. And the programmers themselves only had access to these single-hand punch card machines, so they would hand punch their own cards, and then they would learn to read the holes. So it's a skill in its own right, and they found that if they wrote their own cards, they got more accurate results. So even if it took them away from programming and into that coding part, it meant that you weren't, after 3 days, getting a false result back. You're actually getting the work back you wanted. And you had to be right. You had to get your code right because you took 3 days for you to get results back. You'd also bounce between programs. So you'd work on one program, send it off to the computer room, work on another program, send that off to the computing room, work on your third, and then your first program will come back and you sort of look at the results, change your code or whatever. The programs you're working on these days are really a lot like Jupyter Notebooks. You basically had a script you're running against data. It wasn't until a few years after this we started looking at things like actually system interaction, like you had a database you're interacting with. In these era, you were still doing things like writing to magnetic tape. You were still working out where files were. You didn't have a file structure. You were having to write data to tape. So you're dealing with devices directly, which is quite astounding, really. As we moved on in history, though, we started having this idea of systems. So we started having like file systems and operating systems. Not the systems I'm going to be talking about, but there was definitely things you could interact with. So your applications became more applications than scripts. They become long-running programs. At that part, we started to have the idea of software architecture. We also got things like editors, things like Vim, Vi, Nano, those kinds of console-based editors. So you could write your code interactively. So you spend less time. The cost of actually writing the program, the coding part of it, goes down and allows the program to spend more time and effort on thinking about solving the problems. But as we have applications, we started to have the idea of architecture of applications. It wouldn't just be a thing that starts at the top of your program and just runs the program next to the bottom. It'd be a program that is running for longer. We started having modular design of programs. You start thinking about how we're going to test programs in a unit test sort of way. You start bringing the concept of object-oriented programming as well. So architecture at the software level becomes a thing, and you start having people thinking about how you should structure programs, how you can break programs into multiple programmers. You have lots of people working on the same thing. So we come up with this concept of architecture is, as a verb, is designing as opposed to implementing. Just as the original programmers were programming as opposed to implementing, architecture still remains a slightly higher meta way of programming. You're designing the structure of it without actually start working about the actual logic of individual functions. So programming still remains the logic of the functions, and architecture remains that sort of how does it all fit together. Going a bit further, I would say that most modern programmers are actually software architects. Like we now as programmers understand, if you're a mobile developer or a web developer, you understand the architecture of your application. You understand how React works or how Swift works or how a mobile application works. And you start building applications to have architecture built into them. You start worrying about things like testability, you start worrying about those elements. It's not necessarily your job title, but it is a function of programming. So programmers are inherently software architects at some scale or another. in my career, I found that sometimes you do more architecture or less architecture, depends on the team you're working in. But this is a fundamental part of it. Now you can, though, separate that idea of job function and job role. So if you're able to take someone out of doing programming and say you're just going to do software architecture because the application is big enough to require it, more enterprise applications or your core systems, then you actually are able to separate the doing from the coding, programming from the design, and you get some really big benefits if you're capable of doing that as an organization, which not all organizations can. Small organizations don't have the spare resources to be able to have people do the separate job roles. But if you can, you get the benefit of better documentation because the architect has to write something down, do a design, and hand it over to the actual person doing the implementation. You also then immediately get, in a good organization, in an open and welcoming organization, immediate feedback. The developers will tell you that the idea is a good idea or a bad idea. So you start being challenged on the architecture. You start realizing that stupid ideas or ideas you had when you were tired won't get implemented because you get that feedback. So that sort of feedback loop is really important. It forces that iterative design because you go around that loop. Say, okay, well, what about this? What about this idea? So yeah, straight away. Also, it means that if you've got that level of documentation going, then it becomes something usable. It becomes something that could be used to if one of you leaves the company, or if you have an auditor come in, it's something there. Yes, here is actually how our system works. It's documented. When someone joins, they have a document they can go to understand. Now you start scaling. And there's lots of types of architects. We talk about software architects. Now we have things like database architects who are not only doing, what are individual tables, where's my foreign keys, but also like what type of tables we're using. We're seeing technology like mixed tables. Nordev had an excellent presentation about having a table where maybe your older rows are archived off to an S3 bucket, but it's still presented as one table to the application. So you can mix your table types. Things like that are becoming really cool technology. Network architecture, what subnets are you going to be using, what firewalls, what routing, what VPNs, keeping resilient servers up. Cloud architects, no one knows what cloud architects do. Who knows? It's a fancy word you say, yeah. Process architects may not always be computing related. Process architects, especially in manufacturing, talk about where data comes in and out, where stock comes in and out, how orders work. Some places an order on a website, it gets validated, stock gets deducted, billed, invoiced, and so on. So process architects are very, very powerful sort of architects. I didn't list system architects here because I think first of all we should define what are systems. I had mentioned at first computer systems, operating systems, but actually I looked it up in the dictionary. That's the easy way to define things. A system is a set of things working together as parts of a mechanism or an interconnecting network. A complex whole. I love that thing, a complex whole. To me, a system is any two applications, or an application running inside of other applications. So if you have a website, is it running a web server behind a static firewall, behind a WAF? That's a system or something. If you've got a mobile app talking to some APIs, that's a system. Two separate applications. So you start talking about how those things interact. You start talking about where data is, how authentication works, how secure it is. You start looking at simple things like just what your URL patterns are. All I think are system architecture as opposed to software architecture. It's another layer of meta-ness on top of the architecture stack. So I like to think of it as a scale. On the left hand side, you've got coders who are just writing code, spending time, I'm just churning out code. Is it compiling? And when you're in that coding mode, you're thinking about, is my code syntactically good? Is it maintainable? Maybe. As a programmer, you're thinking about logic flow, you're thinking about edge cases, you're thinking about function by function, how these things interact. And there's a grey area. You may notice here that these aren't actually lined up. I didn't line up stuff into code programmer. There's a blurriness here between coder and programmer. There's a blurriness between programmer and software architect when you start thinking about structural classes, and that varies language to language. When you start thinking about database structure, when you start thinking about interaction, those things, you then start coming into system architecture when you start talking about, okay, well, how does authentication work? Because some of that's down to a software level architecture and some of it's down to a system. So I want to use tokens or I want to validate these things. Then exactly the implementation may actually be on the software architect or it may be on the system architect. Someone stopped me at this point and asked me, was this a scale of pay? And the answer is yes, 100%. The people on the left here get paid a lot less than the people on the right, because on the right it's got the word enterprise architect. Enterprise architect is the most pure form of architecture. It is talking about how architecture is done. It's making those decisions that are good for the business. It's understanding a lot more about business process than necessarily computers in their own right. So enterprise architecture is starting to talk about, well, this is how we're going to make decisions. This is how we're going to decide. If you've got two architectures you want to implement, enterprise architecture is how do you make those decisions? What questions do you ask to sort of score them up and go, this one's better than that one? So a systems architect at the very high end is starting to think about much larger scale problems. And I like this as a sort of thing. And I thought I could also show the sort of activities you would do on this scale, sort of questions. So programmers are starting to think about languages they're writing in. They're starting to think about unit testing. They're starting to think about how they may, like, we're going to use Git workers, I'm going to use Jenkins. Where software architects and systems architects will begin to ask questions like, let's Dockerize it. How are we going to deploy it? How are we going to cause these things to interact? Are we going to use things like load balancers? Whereas a programmer may just go, no, I've written my code, my function's great. Whereas a software and systems architect is beginning to think about, okay, how do we make that scale up? How do we use those functionalities? Enterprise architects, system architects are very blurriness here, and they start talking about, well, where's the commonality between all my APIs? A programmer's got, I built an API, it's fantastic. Systems architects are saying, okay, is it using the same authentication as everything else we're doing? Is it using the same style of JSON, i.e. is JSON structured in a common way? Could someone consuming one API easily consume this API? So yeah, I think this is a great scale of sort of, not necessarily career progression. I don't want to say career progression because I've met programmers who are amazing programmers. I met coders who are amazing coders but rubbish programmers. I think I'm a better programmer than I am coder. I think there are people out there who are language lawyers, for want of a better word, who understand the language very, very well, but don't necessarily understand business. Like, they don't understand what a good program is, or a good program for a business to have. So yeah, I've also met people who are amazing programmers, amazing software architects who don't want to become system architects. They don't care about learning how different things interact. And so as you move up this scale, I do use the word up there, I do think you actually become slightly more generic. Because I think when you become a systems architect, you have to know a little bit about everything, and you rely on those subject matter experts a lot, which I will come on to. But you rely on your programmers telling you what the program can and can't do, what the language can and can't do. You rely on your database engineer saying this is a good or bad idea. You rely on those things, and it's your job to represent those people back to the business. There is a massive crossover between business analysts and architects. I think that in my job, I've found that I've had some business analysts who are very good at understanding business requirements. There's a great line by Henry T. Ford. He said, if you ask people what they wanted, they'd say faster horses. And that can be the case for a computer architect. If you ask people what they want, they will tell you what they think they want. They won't tell you why they want it, or they'll be very, I just want to go fast. They won't say, I want to go faster, so I want faster horses. And of course, what did he give them? The motor car. Like, it's not a faster horse, it's something different which fulfills the same function. So often, what does an architect do all day, every day? What did I do as a system architect for many years? Was I talk to stakeholders. I spent all my time interacting with stakeholders, and stakeholders will lie to you. They don't always mean to lie to you, but they will. So they tell you what they think you want to hear. They tell you things that they think will keep their job safe. They will tell you they want faster horses, and it's your job to sort of tease out some of those invisible things that they're telling you. So you look into them and saying, well, what is their technical ability? Are they able to use these systems? A couple of times in my career, I've made absolutely horrendous architecture decisions where I've overestimated the technical ability of someone, or we've built something which is over-engineered. But a lot of the time, it's balancing that. It's saying we're going to build a little bit, minimum viable product, get it out the door. But you look at also the availability, and stakeholders isn't just the person who is going to be using the product, or the customer, or the consumer. It sometimes is the developer. It's sometimes other business units. And the developer, and we've had this situation before where the team wanted to move into using graph databases in a big enterprise organization where there was a specific database management team, and that team wasn't yet ready to start taking on database. That team was still trying to get a lot of their big databases under control at the time. There's some very big projects that year, and they were basically saying, don't start this year. Don't keep using the database we've got this year, because they weren't ready to start doing the support. They were capable, they had the skill, but they didn't have the availability. And as a organisation that was spending millions of pounds, the business risk of losing a database would result in millions of pounds. We said, okay, we understand that. We won't use it this year. But that was very difficult on us, who wanted to use new tech, and we were being held back by the team, or we felt we were being held back. But the reality was, it was the right decision for the business, that we understood they had the skill but not the availability. It's very easy to double count your resources. Go, oh, the DB team will pick this up. The DB team may be busy. So that you sort of interact with these stakeholders, and as I said, they all lie to you. And when they're not lying to you, what they're doing is they're giving you absolutely unrealistic expectations, or conflicting. The other thing they like to do is give you conflicting requirements. The example I like to use here is ITsec and legal. So ITsec would say something like, we want you to email the customer to verify that their email address is correct. And legal would say, you're not allowed to, under any circumstances, email the customer. And there's obviously a conflict here. And you have to take those requirements and you have to go back to them and you have to say, hey, I know what you said. I know you said never email a customer, but I need to. We need to inform them. We need to tell them about changes to the system or changes to your orders, whatever. You've also then got standards and regulatory bodies. You may have an internal customer saying, hey, I just want to put this on the website. And the regulatory body will be like, nope, you can't share those particular brands on your website. You can't re-show those fonts. You can't use that service in that way. Lots of regulatory things come into play. So most of my time, and I went into this saying, oh yeah, 90% of my time was talking to stakeholders. Reality is, I spent maybe half an hour a week doing architecture, actually coming up with new interesting architecture, half an hour or less. I spent every morning preparing for meetings, and then every afternoon I would have meetings. So I would basically spend my morning preparing for the next batch of meetings. I'd go into those meetings prepared for them, go, yep, I've got my diagrams ready. I'd try and send my stuff out before the meeting. So you're stuck in this cycle. You meet with stakeholders, they give you all different inputs. You then take that away and you have to think about that and have to resolve them and work out what did they say that impacts your vision of the architecture. So you go in this loop and you say, okay, fine, I've got this idea. Most importantly here, I've got sleep on it. Like I think sleeping on architecture is really important. I think someone comes in and says, hey, I've got this idea. You start on these ideas, go, okay, I know what you said, you want to do some function, you want to add some features to the applications. Start thinking how that might work, but go away and sleep on it and come back the next day. The number of times that we've come back the next day and gone, actually, there's a better way of doing it, or there's a more moderate way of doing it, or actually, is this really what you want? It can be very tempting to get caught up in the technology and not ask those business questions. So I always think sleep on it, come back the next day. So I would always say, if I had architecture, I'd say, I'll get that back to you tomorrow, or I'll get it back to the day after, because I knew I had meetings the next day I had to prepare for. So looking at my calendar going, yep, let's book a meeting in for that day and I'll have your stuff prepared for it. So you write it all down, you write down everything. I'll talk about writing stuff down in a moment. But you send it round and you wait for feedback. Don't wait very long, because if it doesn't come straight away, it's not coming. People are busy. So what I found was that some people, there's a couple of people in particular, were fantastic. Like, I'd send stuff around, they'd come back to you with comments going, okay, this diagram here doesn't look right, or could you clarify this line? Allowed you to fix the stuff before the meeting. Like, understand their point of view was really fantastic. And thank you very much. A lot of people were very busy. So I would find that in enterprise organisations especially, you would book a meeting to go over the stuff. So one of the big things that I'll get on with is I wrote a lot of PowerPoint decks, a lot of presentations, and my presentations weren't for standing up and presenting like this. There was stuff you could go and read, and it was controlling that flow of information, saying, understand this slide before you go on to the next slide. So my presentations had a lot of information every slide. So you'd have those meetings again with those stakeholders, saying, okay, what do you think about this architecture? Do you have concerns? And then they'll give you more feedback, and they'll tell you stuff they didn't tell you the first time round, and you go around this loop again. You go around this loop until either everybody stops complaining, or the developers are saying, we need to start work on this now, and therefore you hand it over to the developers. But it's a very agile process. It's a very modern, don't try and do waterfall, don't try and define everything to its 10th degree. do it agile. So understand what the requirements are, understand what you need to do first, break the architecture down, solve individual parts of it, then come back and look at it as a whole. Because that's what system architects are doing. They're looking at the problem as a whole, working out where the blockers are. So this is what the challenge actually is. The job, not being an architect, but the job is actually convincing people to be more consistent. It's about moving towards the best of all possible worlds. So it's about saying, okay, well, you've built an API, let's make all our APIs JSON. Let's make them all JSON RPC. Let's them all follow the same naming convention, so that when people are consuming the APIs, they're consistent. That's architecture. Now, saying it is one thing. Getting different development teams to follow you on that journey takes a lot of effort. They've got their own ideas, they've got their own legacy systems, they want to grandfather some in. It's like, okay, we've got to move towards this. We've got to say new systems will follow the new spec. New systems will be behind the same authentication platform. And it's hard because it's easy to just do what you've always done. It's easy just to keep doing it. It's very hard to change a juggernaut, especially with an enterprise system. Especially when you've got customers calling those APIs. It's incredibly difficult for some customers to move onto new APIs. When they turn around going, we're not going to do that this year. And we're spending, £50, 60,000, £1 million, $1 million. Your salespeople get very nervous about you telling them you have to move on to new APIs when they're spending large sums of money. There are architectural things you can do to put a shim in front to make it look like the same API, but then sort of ease them onto the new one. But it's difficult. It's very difficult to get different teams building in the same way. And this is what I spend a lot of time doing, is talking to them, saying, well, what's the challenge here? What's the good thing from the way you're doing it? And incorporate that into the new system. So incorporate the good parts and try and get rid of the bad parts when you're moving forwards. And this is crucial as well, is that good architecture is not always good technology. This took me years to understand, that sometimes the best solution for organisation is not the best technology or the most fun technology or the most fancy technology. I did a contract as part of Proxima with an organisation called Diageo. Diageo sell Guinness. They make and sell Guinness, amongst other things as well. I think they own Bacardi, maybe. And they had this project where they wanted you to walk into a pub with an app on your phone and claim money off Guinness. So it's a hot day, they send out a push to all their people with the Guinness app, get money off. Really cool. But they didn't actually have a relationship with the pubs, because the pubs get their Guinness from a distributor, and the distributor buys it from Guinness, or maybe from another distributor from Guinness. So they need to make sure that when you go into the pub and get 20 pence off, Guinness pays that pub 20 pence. And they were very worried about merchant fraud. They weren't worried about consumer fraud. Anyone could get 20 pence off. They didn't care, but they were worried about merchant fraud. They were worried about merchants saying, "Hey, I'm worried that I've sold 5,000 pints of Guinness today. You owe me lots of money," and they pay out, and their marketing budget would overrun. So I designed a system with the help of some friends, and we had this system in place with NFC barcodes in pumps on Guinness bars. It's amazing. All rolled out. I went into Guinness with the BA, the project manager, and I presented a foolproof way of cracking all merchant fraud across the entire UK. And it was amazing. It was really good tech, really well thought out. And the guy there was like, fantastic, how much is it going to cost? And I said, about 20,000. Which was a fair price, actually, for the work I'd done, or the work that we were planning to implement. And the guy laughed at me. And literally was like, yeah, no, we're not going to pay that. And he said that the actual amount of merchant fraud they have, because you can sort of tally it up at the end of the year, the actual amount of merchant fraud they had was way less than that. They would rather pay the merchant fraud than pay 20 grand. It was cheaper to pay the merchant fraud. So I had misunderstood the business requirements. I had misunderstood the scale of the solution. I had over-engineered it, maybe. I had stomped out fraud, but at what cost? And actually, the solution, we redesigned the solution, we went back in and we built a much cheaper solution, which probably stomped out, 95% of fraud, but at a fraction of the price. And I think that was what was really important about this project. It was really important to understand the business need and the requirements there, rather than just going technology. Best technology is the way forward. Do the best job you can at the technology level. Good architecture is not always. So I started asking myself, how do I quantify, validate, sort of score my architecture? And we all know what SMART is, because we all do HR forms, and you're all told you have to have goals, and your goals have to be smart or smarter goals. And I agree with this, actually. I think that if you have a goal, you want to be able to say, I've been successful or not in my goal. And SMART is a way of saying, being able to say, are you being successful or not? I.e., it has to be specific, it has to be measurable, it has to be relevant and time-based and attainable. And the reason for those things are that if you have goals which aren't relevant, then there's no point in doing it. If you have architecture which isn't relevant to your business, like a fraud system which is too expensive, it's not good for the business. So you need to be specific as well, because your architecture doesn't need to be so big. It needs to be broken down to usable consumer product. It needs to be measurable in that you say, if you start building it, how complete are you of the vision? How much is minimum viable product? Where are your stretches? If someone comes back and asks for a feature, is it clear what has to be done to make those features work? It has to be attainable. Are the teams capable of pulling it off? Are you going to use new exotic technology which no one knows how to build yet? Is there time for them to build it in as well? Other projects may be going on, and you may scale back some of your visionary architecture because of other applications that are also being built by the same teams. It's a very complex structure, but I think smart architecture, start scoring yourself going, is this a good architecture, or is it sort of your own pipe dream for what you want to build? Fundamentally, the biggest problem I found is that companies have a finite amount of resources. And resources means your time. It means your developer's time. And I think that to be successful, you have to pick what you want to do well. I realise there's a typo there. Every time I do this, oh look, there's an extra apostrophe there. There's also somewhere a half-written sentence. Oh yeah, there. Are there other? Yeah, fantastic. 2 slides back to back with mistakes. Do what you want to do well. For everything else, don't do it. Straight away, just don't do it. That doesn't mean to say never do it. Put it on the backlog. Do a shortcut. Make it tech debt. Whatever. Or outsource them. But outsource, I don't mean get contractors. What I mean by that is maybe there's off-the-shelf products which do what you need to do, and you just need to configure them. So I'm a big person. I like using Nginx. We started doing a lot of proxy paths sort of, in Python sort of things, whereas we could replace that with Nginx modules and save ourselves a lot of developer hours by using Nginx correctly. I see people try to make web shopping baskets. Like, why? Just use a shopping system and configure it correctly and build the process, work on other systems, billing systems or whatever, but use a shopping basket system from another application. So yeah, do what you want to do really well, and then everything else, just don't stress about those things. There are solutions that you can use which may not be perfect, but they'll get you there. A good example of that is things like we have a system and we needed to use a federated system, a logging system. So I could write it and get the developers to write code to interact with AD and interactive LDAP and all that stuff, or just tie into Okta. And tying into Okta has some expense with that, but it was definitely a better use of our time to tie into Okta and use Okta as a bridge between systems than it was to try and replicate all that. Okta do that much better than we could on our own. We're well on track here. It's on to phase 3. So phase 3 was some tips and tricks about how to do architecture, and I've got to make sure I look at the right diagram at the right time. I've got a printout here, so I know where I'm up to. First of all, when you're doing architecture, realise that all your stakeholders are different. Mostly, I would say, the stakeholders, your boss, management, corporate, even the developers don't have time to read. So stop writing mega long wordy documents because they just don't have time. They want to be doing their job. They're not there to just read documents. So I would say that most people prefer to have diagrams. They prefer to have a short summary than a massive Word document explaining all the bullet points. Some do need the detail. They want the detail. They want to challenge and go, okay, where was this thing you said? Where's that backed up with evidence? Very rarely, but I think most people want a diagram. So I think that diagrams are the way forwards, because I think if you make exec summaries, by the way, it took me a long time to understand that executive summary is not an introduction. Executive summary is the entire document written in 2 paragraphs. And there's an art to writing a good executive summary, and the art is to being honest without losing the detail. It's very difficult. It is a challenge. So I think the first thing is to understand the difference between formal and informal documentation. I think some places only do formal documentation and no informal documentation. But actually I did probably 80% of the documents I produced were informal, maybe even more were informal. Because they're quick, they're cheap. You put them in Slack, you put them in Confluence, they're note-based, and they're fast to change because you haven't put a lot of effort into them. You make a mistake or someone comes up and gives you feedback, you sit there and go, okay, I'll change that now, and it's not a big job to change your entire document. Whereas formal documents, the notation is much more correct, it's all laid out correctly, so making a change becomes a bigger, more expensive task. I would always write an informal document and then upgrade that to a formal document if it's needed. Formal documents are needed if you are taking a document external, in my opinion. I would not give an internal document to a customer. I would say, I may show it to them saying, okay, I've got a document that explains this, but I'm going to need to weigh in top and tail it. Well, of course, top and tail it, put an intro, put an outro, just check on my spelling and stuff. So auditors and customers got formal documentation, whereas everybody else gets informal documents. And they like it. I found that to be a much more easier way of doing it. Formal UML is often not worth it. This started a bit of debate, and I stand by this, by the way. Formal UML, first of all, UML, a unified markup language, is quite an old concept, and it was designed by committee. So it has lots of quirks, which the committee brought in. It allows you to define pretty much any kind of architecture you like. You define interfaces, you can define classes, you can define your application, every single function in your application in UML. You can define systems, you can define networks. I would say it's often not worth it because a drawing on a whiteboard is faster. Now UML does have benefits that if you want to change it, you can commit it to Git and then come back and say, I'll add an extra node and it just updates your diagrams for you. But I think the modern diagramming tools are better. Someone also asked me, saying, if you're defining class interfaces and sort of prototyping code and testing business cases from it, does that mean that I think Celery and Gherkin and things like that are not worth it? And the answer is no. Celery and Gherkin are modern versions which took all the mistakes from some of those precursors like Business UML and updated it. Someone else said, but UML started out as a way of defining business cases, so you could define business cases and score your application whether it's successful or not. And I would argue if it was any good at that, you'd still be using it. So I think formal UML. That said, plant UML is quite cool. If you want to make ad hoc diagrams, plant UML is quite cool. I like to drag things around the school. I'm old school. And by the way, some of my architecture I do in PowerPoint. I know 4 boxes, PowerPoint's perfectly fine for doing it. Use what you're good at. I use OmniGraph and PowerPoint heavily. Lucid Chart I don't like. Personal preference. If you want to be a good architect, my go-to point would be to master 1 or 2, maybe 3 diagram styles. Really understand how to draw that diagram and have consistency of design and establish a well understood shorthand. And I'll show you what I mean by this. This is 2 flowchart diagrams. The one on the left is my informal version, the one on the right is my more formal version. But if you note, I also got rid of my diamonds. So if I go back to the very first slide, this lady here is drawing, these diamonds are if statements basically. If, yes, no, true, false, kind of back. I've got rid of those completely. And what I have now is, I just basically have the same thing saying, these are all basically sub-functions, sub-processes, technical flowcharting. I've said, yeah, if it's errors, go over here, if it's okay, going here. Now, interesting note, my golden path goes straight up and down the flow. Really important that this is straight. Any edge cases go off to the side, done on both diagrams, which means when I'm looking at it, it always goes from the top to the bottom or from left to right. Super important that you do that. In the Western world, we learn to read left to right. We learn time runs left to right. Comic strips run left to right. That's because that's how time works. So the earliest event goes at the top or the left and goes to the right. So looking at this, you scan down the page and left to right. Possibly in other cultures you might not. some of the Arabic I think is right to left. I would suggest possibly your diagrams still want to go left to right, because most computer programs are done in an American way. It's a whole debate for another day about whether you should use Americanized spellings in your class names. But left to right is key. Being consistent is more important, but left to right. So whenever you draw a diagram of web requests coming in, they will come in from the left and they're applied to going back. So on the left here, I've got this Informal. I've got a handwritten font here. I use a font called Claire's Hand. There's a different line to show this is the line it's talking to. By the way, all these diagrams are completely made up for this presentation. I've got KYC, your customer callouts, but they're completely made up. They're not actually taken from anything I do at work or any of my jobs. I made them all from scratch. If I was to make them more formally, I'd do them like this. I'd actually have callouts here, and I'd have a table underneath in the Word document or the conference page or whatever, which outlines exactly what those bullet points are. And this is nice because it means I want to add more detail underneath. I just type more in here, and if I make a mistake, I just edit this. I don't have to republish the diagram. But on the other hand, if I come and add a box in and want to put a number on it, I have to redo all my numbers underneath. So it isn't always better to do this. This is why can be more expensive to do your diagrams in a more formal way. But the thing is, it's well understood. If I do it this way on one of my diagrams, I do it this way on all my diagrams. I don't flip between the styles. If I'm doing formal, I'm doing it all the way through. So someone looks at the diagram, they go, yes, I know what this number means. I know to look at the table underneath. I said these are flow diagrams. They're actually sequence diagrams. I don't know why I put flow on the top. I was running out of time to write the presentation. In this, I've got a browser, maybe a bit of JavaScript to the browser, calling some APIs on the server. That API is going to call some subsystems. This is basically showing the interaction between systems over time. As time progresses down, then I'm sending a message in and I'm getting the response back. Then some kind of email is being sent out from Postmark and they're typing that code in. So you can very quickly see I'm calling register followed by auth code. It's only showing golden path because it doesn't show, well, if you didn't get the OK here, then don't do the next step. Like, it's sort of only showing that golden path situation. So you might draw lots of these for different situations. This is an informal diagram because I've got that handwritten font. I also use this little curve line so you sort of know it's not a data line. And I also haven't got these lines going up and down here. This is only a short-lived system here, so I put the subsystems here. But it's clear. People should go, okay, I know I call register, then I call auth code, job done. And they can understand they get a redirect here. And the next line would be, okay, now go to dashboard. Yeah. So common stuff is ignored. It also works very well if you have other things like API documentation. So if you've written your docs in Open API standards or RAML or anything like that, then this works very well because you can say just look up the register docs for actually what data you're passing in that call. But as an interest, saying you're going to call this, then there's another function. When you start looking at your API docs, you know which API you're going to call, because sometimes those are in alphabetical order, not necessarily in the time order. So you want to do a particular sequence, like registering. This is the process you go through. I would say probably the two diagrams I draw the most are flow diagrams, and the next diagram I show is sort of like a system interaction diagram. This one's really good for time. It doesn't show you necessarily how the components are linked together. This is a diagram, a sort of diagram I got asked, which I think you shouldn't draw. Okay, this is a diagram which shows every single component. I've got two variability zones in AWS. I've got a load balancer, I've got Cloudflare. They've got this stuff running at the same time both sides, so it's showing all the redundancy, it's showing all the ports. It's horrendous. It'd be much better if you drew this diagram. Again, it's going from left to right, it's showing a request coming in. There will be a response going back, but it's understood. The people giving this to are clever people. They don't need to baby feed them little bits of things. Okay, it's going to a load balancer, so traffic's being split up into one of these three applications. You could send the notes. By the way, these are redundantly hosted in different availability zone. You don't have to put it on the diagram. You could just say, yep, I understand the data flow is into load balancer and then it's been split onto three systems. This one also sends to an SQS, which sends to worker threads. It's neat. It's straight lines. If you're going to use curve lines here, use curve lines throughout. Don't have straight line here and curve lines here. Use straight lines throughout. The other thing I would recommend is try not to put words on the side if you can help it. I use shorthand LB rather than application load balancer. I've lined up the top lines here and the bottom lines line up, so it's sort of balanced. It feels balanced, it feels natural, it feels good. People won't question this architecture because it feels right. However, they will question this architecture it's exactly the same architecture, but straight away looking at it, I sort of put both side by side. The one on the left feels wrong, and the one on the right feels more mature. It feels like someone's thought about it. So putting the effort into just making the boxes the same size and spacing them out nicely. And most modern tools, Omnigraph or Visio, those tools will auto space out evenly. I've also got 3 layers here going on, so my SQS and my RDS are level with each other. As they line everything up. Sometimes you will draw a diagram like this in a meeting if you're doing it quickly, and then you'll go away and tighten it up afterwards. But sometimes you also want to convince someone to select the right one of 2 options. So you may draw one a little bit sketchily and the other one perfectly, and they'll sort of be drawn psychologically to the one you want. And so you can use this for evil. I'm just saying, like, if you go back and if any of my old bosses are watching this presentation, you should go back and check some of my diagrams, because I'm not saying I did that, but I totally did that. Last tip. You have to be confident in your architecture when you're talking about not just your ideas but other people's ideas. If you've gone to a database person and said, I want to build this system, it's your job to represent those ideas, and you have to be confident when you're doing it. You have to be saying, this is a good idea, this is a bad idea. Sometimes these things are subjective. Sometimes you get to 2 architectures and you can't necessarily say which way to go, so you go with the one you feel most comfortable with, and it's subjective sometimes. So you should believe in yourself and you should believe in your architecture. If you don't, you should say that. You should be honest about that, and you should say, hey, I'm not sure about this bit, or I've got this bit worked out but I don't know about this other bit, and you go to people and get their feedback. If you say, I don't really know how the auth works, or I don't know how the sign-up process works, work it through with someone. Be honest about it. Don't bluff your way through this. This isn't fake it till you make it. This is be honest. You can do this, but you've got to be honest. And I think in my career, I learned very early on. I brought up being honest. My dad's watching this, but I learned very early on that if you're honest, people will know that you're honest. If you take someone else's ideas and present them as architecture, always say, hey, this is backed by this person who gave me this idea, it's their concept. I've just fluffed it up. I've just drawn some nice diagrams. And some of the best architecture I've ever presented has been other people's ideas. I've just drawn the diagram nicer. I've communicated it better, or I've taken their ideas and someone else and merged together. Okay, this is how we're going to deliver those ideas. And if you're honest about those things, people will listen to you and respect that and go, okay, you're not just out to steal glory for yourself. So it's really important. I've had the very thankful that I've had some fantastic bosses who have also been respected for their honesty. When I'm dealing with clients, I deal with clients with people like MasterCard and some other customers, and they were always very, I think, thankful that we were honest about how the system worked. We said, okay, this is what's good for the consumer, this is a good idea, this is a bad idea. Sometimes that we had a project with a customer we had to cancel halfway through because we worked out it couldn't be done. We worked out the technology wasn't on. And that customer was very thankful, so thank you for letting us know before you got to the end of the project. We'll just spend the extra money with you guys in a different way, doing something more fun, more interesting. So yeah, it has worked out very well. I think being honest is crucial. If I had to do it all again, if I went back, I think one of the things that I would change about the way I've done it is I would start listening a lot earlier in my career. I've been very technology focused. I think understanding the business requirements of what my systems do. Also the environmental impacts. I think only in recent years, last 10 years or so, I've been very aware of how much electricity costs. So designing systems to be lower maintenance and lower energy usage, I think is now crucial for going forwards. We should all design systems with lower energy usage. But apart from that, I think, I master those diagrams, be confident. That's the way forwards. Anyway, we're at 48 minutes, so thank you very much if you made it this far. Congratulations. My name is James Taylor. I am on Twitter on jmons and _invalidentry. I am more than happy to take any questions, feedback, anything you like. Put them in the comments, message me, Discord or Twitter. And also, lastly, another shout out to NordevCon. NordevCon, the conference is unlike any other conference I've been to. I've been to a fair number of AWS conferences, Nokia, BlackBerry, those organizations don't exist anymore, but also security conferences where usually it's one product or one topic. Python conferences, everything's just about Python. Nordev isn't. It's about computers, technology. It's about learning, it's about testing, it's about all these different topics all bundled together. And you get people with very conflicting ideas, and they sort of learn off each other. It's two, sometimes 3 days, 2 days in Norfolk, and it is absolutely amazing. And it's also a lot of hard work by the organisers, and I just want to thank the organisers, everybody who put so much time and effort into making it a really worthwhile conference, and all the other speakers, because I did this talk and I went and listened to a lot of talks. It's also, Norfolk is a very small tech community. It's an amazing tech community, but you get to know these people, and I haven't seen some of these people for a couple of years because of COVID. So I'm going to really thank the organisers and the King Centre as well for where we hold it. Absolutely amazing venue. So yeah, I hope to see all of you next year at Nordev. In fact, if I could get a link to say buy your tickets now, I would say put it on the calendar, buy it now, because it's such an important time. Well, thank you very much. If you hit like and subscribe, I will be thankful, and you will be able to get more content from me on this channel. Thank you very much.